Hello everybody. Today's lecture is on algorithms. So I know everybody's probably eager to start programming. I don't blame you because programming is a lot of fun. But before we get there, it is important to understand what we need to do and how we need to plan in order to have a successful program. The proper way of program design and development has the following steps. First of all, we need to think about the requirements of the program, meaning requirement analysis. In this step, we need to investigate and answer three main questions. What are we trying to build? What are the program's inputs? And what are the program's output? In other words, we need to figure out exactly what we want or what your customer, your client wants. And then your program is basically the black box, and you need to figure out what are the inputs and what are the outputs. So for instance, if your program is a calculator, it would, as input, it would take numbers and the operations that are going to be performed on those numbers, and it would provide an output. If your program is Facebook, then each operation is different. So for example, your program takes a username and password, checks them, and the output would be it would log the users in. Then in the next step, once we have this established our requirements, then we need to think about algorithm design. So what is algorithm? It's you need to describe how you want to actually solve the problem. So once you are sure, once you know of the inputs and once you know of the outputs, then you have to think about what steps you want to take to solve the problem. So basically, the steps that we need to follow are as such. First, we need to understand the problem. Then we need to develop and describe an algorithm. Then the next step is to test the algorithm with simple input just to make sure it works. And then, and only then, you would program the algorithm. And lastly, but certainly not least, you would compile, run, and test your program. In fact, as you're programming, you keep on compiling and testing your program. But you would never start to program out of nowhere without planning things properly and making sure that you have developed and tested an algorithm. So I've said this word algorithm quite a few times without properly defining it. So let's move to the actual definition. A sequence of steps that is unambiguous, executable, and terminating is called an algorithm. So that's very important. I'll talk about this a little bit more. Also, I wanted to say that you can show an algorithm using a flowchart as well as pseudocode. Pseudocode is basically writing it out. It's a bit of a lengthy process and it might be hard to read. Flowcharts are generally recommended, but they're both used. Flowcharts are just a lot easier to follow, so people use flowcharts for this quite a bit. So when you think algorithms, you need to think about if you have a younger siblings, like if you have a 5-year-old or a 10-year-old younger brother or sister, if you had a mathematical equation and you wanted to explain to them what to do, how would you explain that to them? You need to explain that very much step by step. And so if you forget to mention a step to them, then they would get lost in doing that equation. Or an example that I always use in my classes is that imagine you had a robot. If you wanted to tell your robot to go to the kitchen and get you a glass of water, how would you explain that to them? You can't just say, go to the kitchen and give me a glass of water. You need to tell them exactly what to do. So you need to tell them to go to the door, open the door, go into the kitchen, go to the faucet, turn it on, put the glass underneath the faucet and fill it up with water. You also need to remember to tell them to shut the water tap off. If you don't tell them that, then the water keeps on running. So every instructions need to be there. When you program, you can't take anything for granted. You need to be very specific and you need to define your steps quite a bit. Programming is a very logical practice, so you need to make sure that you define what you want to do in logical and precise steps for the computer to understand. So let's see what is pseudocode and what is a flowchart. So pseudocode is an informal description how to solve a problem. It's not in any particular language. There's no computer jargon like C++ or processing or Java. It's simply English and in point form what needs to be done. Again, an algorithm, pseudocode, or flowchart, it needs to be unambiguous. That is, it needs to be very, very concise. You can't have any confusion of what steps to take. It needs to be executable, so it needs to be able. Each step can be carried out in practice. It needs to be terminating, so it can't be an infinite loop. Eventually, it needs to come to an end, and then it will qualify as an algorithm. So let's do a quick exercise here. If you want to write a pseudocode for the following problem, so we want to write an algorithm that write a program that calculates the distance between 2 points. And we basically want to do distance C. So how would you do this? How would you get distance C when you have point 1 and you have point 2? You have sort of the formula, how to get A, how to get B, and also how to get distance C. So it's simple enough, but if you wanted to tell the computer to do it, how would you do that? So let's go over that. Well, here's the pseudocode. First, you have to prompt the user to enter the x coordinate of point 1. So get x coordinate of point 1. You read that from the user. You prompt the user for the y of point 1. You read that. You prompt the user to x coordinate of point 2. Do the same thing. And for the y of point 2, you do the same thing. Then and only then you would calculate side A, then you would calculate side B, and then you would use the formula to calculate side C, and not to forget to finally display the results. This is a little bit too wordy, so like instead of this, if you wrote, for example, if you simply said, for example, get x1, get y1, get x2, get y2, that would also work. So you don't have to make it so formal, even if you were quite informal about it, and just say basically you need these inputs and you need you need these inputs, then that's fine as well. Now, option 2 is the flowchart. A flowchart is very effective and it's very, very efficient simply because of the fact that it allows you to display it allows you to illustrate the entire process of the program. Now, a flowchart has some syntax, and this is going to make things easier to read. So, for example, the start or ending part of it is an ellipse. For input and output, it's a parallelogram. For branching, you have a diamond, and you have, for process, you have a rectangle. You also have an arrow to show the flow of everything. So, a software that you could use to draw these is Microsoft Visio, but you could always draw it by hand as well, or on Word or PowerPoint. You could draw it. So the same thing, the same algorithm that we just did in pseudocode, you can kind of see the same thing here. And you can appreciate how this one is a lot more concise and a lot more easier to see. There are no branches here. So there is no like two ways, like if this go this way, else go the other way. It's just sort of all very procedural. So you would read all the input, then you would do the math and the processing, and you would simply display the results, and you come to an end. I'm going to do another video, and I'll do another example of doing an algorithm in a flowchart. So please check that one out too and get some more practice with doing algorithms. Thank you very much.